Okay, today we're going to finish 8.1. So we're going to talk about outliers. Outliers are extreme values that it's either going to be very much less than or much more than the other data values. They do have a strong effect on the mean and the standard deviation. So a good way to think about this is when you look at your grade book, you can see the average grade for a lot of your assignments. But if there are a bunch of people who are absent on the test day, what goes in for that? A zero. No, I put in a 0. So I know a lot of other teachers do too. They put the 0M in there. So when you have the 0, that's bringing the average down. And then if you go back in and look like a week later, you might see that it moves up, and that's because of the outliers are no longer in that data set. There is a method that we can use to find the outliers. And one way is to look for data values that are more than 3 standard deviations from the mean. So that is how we are going to identify what outliers are. So if we flip it to the next page, in example 1, the standard deviation was the 4.78, so fill that in. And the mean was the 21.9. Okay, so the standard deviation is the 4.78. And then the mean is the 21.9. So to find the outliers, we're going to multiply the standard deviation by 3. So that's our first step. Okay, so if we multiply the standard deviation by 3, we're going to take 4.78, multiply by 3. That's going to give us 14.34. Okay, then we're going to add and subtract that number from the mean, and we are going to represent this on a number line as well. Okay, so for our second step, we're going to take the mean, which is 21.9, and we're going to add 14.34. I want you to find that value, 21.9, and subtract 14.34. And we're going to write what those values represent. That's you. All right, so Cam, when you added them together, what did you get?
I don't know.
Oh, yeah, put that away. Alyssa, what'd you get? 36.24. Okay, good. And then Sarah, what'd you get when you subtracted? 7.57. Good. Okay, so any number that is above this value is an outlier. Any number that is below this value is an outlier. Okay, if we look back at our data set, do we have any values that are above 36.24 or below 7.56? Let's look at our data set. I put it on the first page for you. So any numbers above 36? Below 7.56? Nope. Okay, so then for this set, there are no outliers in this data set. So I said we're going to represent this with a number line. So we are going to draw our number line. And the mean is going to go in the middle. Okay, so this is the 21.9. And then you are going to show that each way is 14.34. 14.34. So when you add, you get 36.24. When you subtract, you get 7.56. That's where we are on the number line. And then any values that are above are the outliers. And then any numbers that are below are the outliers. Now be prepared to be amazed for example 2. So we have to find the mean and the standard deviation for the heights of 15 cans. We're going to identify any outliers and then describe how they affect the mean and standard deviation. Okay, so in step 1 we're going to find the mean and standard deviation. You can choose to use your graphing calculator or by hand. Hint, hint, you're going to want to use your graphing calculator. Now, let's talk about how we can do that. Okay, so to use your graphing calculator, the first thing that you want to do is go to Stat. And then press Enter. And you're going to edit List 1. Okay, that's where you're going to put all of your data values. Okay, so we're just going to press Enter. And then in List 1, you're going to enter all of these. Put all data values in List 1. Okay, so I have 92.8, 92.9, 92.7, and again. Do you guys know what song this is to the tune of? What is it? I don't know the name of it. That's why I want you guys to tell me.
Is it like Missouri Mac?
No, but I know that one. Back to my home, I will not go, for if I do, my mother will say, yeah, down by the bay, down by the bay. Where the watermelon grow. I've never seen watermelon grow by a bay. I know. Never seen a watermelon. I carried a watermelon. Do you guys know where that's from? Please tell me yes. Sarah, you know, right? Yes!
Oh, I love that movie.
All right, your assignment for the next few weeks, you have to watch Dirty Dancing.
Each day for the next 3 weeks. I will do that. I'm blind.
And then you have to do the lift. Find a partner.
You have to record it, not your assignment.
Yeah. It'd be terrible. My kid broke her nose doing your assignment.
It's due before the end of 3 weeks.
All right, now, are you ready to be amazed? Kate looks like she's doubting. You're skeptical. I like that. I'm going to make a believer out of you. All right, first, we will press Stat. After that, we will arrow down to Sort. We will press Enter.
Wait, which sort?
Sort A.
Can you use sort B?
I don't know what happens with Sort D, so if you would like to go on that adventure, you let me know. Okay, now we are going to tell the calculator that we want to sort L1. I wonder if sorting by D puts you there. So L1 is right above 1. So you go second and 1, and that will give you L1. You press Enter. It says done, but what is done? Let's go back to the list. So if I go to the list and I press Enter, what happened? So now they're in order, so that makes it really easy to find what? Put your book away. It's going to be, well, yeah, you're going to have either your outliers at the top or the bottom, but this is also going to help you if you're trying to find the median, right? So if you're trying to find the median, you could use that to put it in order for you. if you had a bunch of values. Oh, but wait, there's more. If you call in the next 10 minutes, I will show you how to find the standard deviation and the mean.
Remind me not to call.
Just play separate shipping and handling. Okay? Now, yeah. Go to stat, arrow over to calc. This thing that says 1 var stats is very mysterious, but very wonderful.
Okay, where are we?
Stat. Yep, we're going to go to stat. Arrow over to calc. We're going to select the first thing. So stat, arrow over to calc, select 1 var stats. I know. The suspense is building. Will Liam Neeson save us? Let's find out. Okay, calculate. Ah. What is that? Thank you. Are you a believer, Kate? Are you a believer now?
I figured
that out by tethering them all into my calculator and
All right, so then let's round to the nearest 100.
Stop flexing all of this.
But did you know the standard deviation is also there? Yes. What symbol is the standard deviation? No, we learned the name for it yesterday. Sigma.
Sigma. The O with
Roll it
Sigma.
upside down for you.
I mean, you're not wrong.
But wait, there's more. What is the n value?
Second.
The number of things?
Yeah, the number of values. Yep.
Big thing opens up.
Oh, but what happens if I scroll down?
There's more.
There's more. It's the min. It's the max. It's the quartiles. It's the median.
Oh my god. And that's why we're gonna have a no calculator portion on this next test.
No, you will have your calculator.
Oh, nice.
Yes.
I
I just don't know when the test is going to be.
Yeah,
So.
that's fair. We're gonna go back over this.
All right. So now we can identify our outliers. Don't act like you're not impressed, okay?
Only case wants to do that.
Yeah.
That's her job.
All right. So now we're gonna find the outliers.
It's okay. I know what you want to
Okay, and then you are going to use your number line. So to identify your outliers, we are going to multiply the standard deviation by 3.
one-upping me with your thing.
All right, so the 0.57. And that's what we're going to add to the mean. So it says use the number line to show your work, so that's what we're going to do. Number line, and remember what goes in the middle of the number line? Your mean. Why you gotta be so mean? I love them. I have a problem.
My only Bible is pens where I have like 7 colors in one pen.
I don't like the way that they look. I like the marker look. Like I said, I'm a little crazy. Okay, so then here's the 93. If I add the 0.57, 92.77 plus 0.57, I will get 93.34. Okay, so you're going to add it when you go to the right. When you go to the left, you're going to subtract. So 92.77 minus 0.57, 92.2. Okay, so then all of your outliers are going to occur above 93.34 and below 92.2. Okay, so we're, shh, stay here please. We're going to check for outliers. Okay, so first I'm looking for ones that are above the 93.34. Do I really even have any that are above 93? Nope. Okay, so what about below 92.2? Yes.
How dare the trail?
All right, so the outlier, which really, if you're looking at this data set, it's not like this feels unreasonable, right? The 92.1, it's just because all of these are so close together. And then we're going to explain why. So there's your outlier. And then make sure that you know how to explain. And we're going to explain using our definition. Okay, so we identified that 92.1 was an outlier because why? Okay, why is that an outlier? We know it's because it's below 92.2, but why does that matter? Yes. Okay, so because it is more than 3 standard deviations from the mean. Now this also says then check. Okay, so when we're checking this, there is an equation that we can use. Okay, so our equation to check is the value minus the mean divided by the standard deviation. So we're going to calculate this, and then we're going to decide what we're looking for. Really, you can think of it, yeah, if we can write it in symbols, your value you can think of as x, your mean is x bar, divided by sigma. Yes.
It reminds me of like a man
All right, so 92.1.
Good. Now you can just suffer with me.
All right, so we are using the absolute value. So 92.1 minus 92.77 divided by, and then we're just going to use the positive value. So 0.67 divided by 0.19. All right, so we got about 3.5. Is this good or bad?
Yes.
Good, because we want more than 3.
Yes, why?
Because then it proves it's an outlier.
Why? Why is 3 the magic number?
Because it's multiply the standard.
3 is more than 1.
Yeah, because it should be more than 3 standard deviations from the mean. Okay, so if this value is greater than 3, we know it is more than 3 times the standard deviation. Okay, so whatever you get here, this value should be greater than 3. Okay, so that's how you want to check it. Now we are going to remove the outlier to see the effect that it has on the mean and standard deviation, and we're going to explain this. Do you guys know the difference between effect and affect with an A? What? If it's with an E, what is that? It's a noun, and if it's affect, it's a verb. Right? So if it's affecting something, it's with an A. Okay, so we're going to go to stat. We are going to go to enter. And then we are going to delete the outlier, which really, if you're looking for the outlier, it's either going to be where or where? The first or the last, right? Okay, so to delete this, all you have to do, select it, delete, and it's gone.
What'd you do? Why'd you get rid of it?
Because we gotta remove the outlier.
You. It was an innocent little bean.
All right, now we're going to do this again. Are you guys okay? I'm just like, hey, are you okay? All
Can you
right.
stop dying for 1 second?
Alex, are you okay?
Oh, he died. Alex died.
Are Kira and Rhea being nice to you?
It was literally just Kira.
It was self-defense.
Don't worry about it. The world is ending.
Pretty much.
You get school off for basically a month and everyone starts going crazy.
You better go.
Starts.
Sucks.
Let me go with hybrid.
I wish.
Okay, and then we'll round to the nearest hundredth.
What's happening?
So we're gonna finish this explanation together, and then if you haven't already filled in your Pascal's triangle, then you can start that. Okay, so we are gonna say what happens to the mean. So the mean was, okay, so the mean was 92.77 in step 1. So what happened to the mean from 92.77? It increased. So the mean increased. Up here, please. Okay, so the mean increased from 92.77 to 92.82. While the standard deviation did what? Decrease. Let's think about what the standard deviation means. Right? Do you guys remember from yesterday what the standard deviation represents?
How far your value should be away from the average.
Yes, okay, so this represents how spread apart your values are. So if you're getting rid of an outlier, does it make sense that your standard deviation would go lower?
Yes.
Yes, because if the standard deviation is lower, that means the closer they are together. So if you're always taking out outliers, really your standard deviation should always be going down because you're taking out the values that are spread apart. But what about the mean? Is the mean always going to be increasing?
It could decrease if you have an outlier that was higher.
Right, so your outlier could be on the other side of the data. So if your outlier is a higher value, that would actually cause your average to go down. Okay? All right, so I asked you to fill out Pascal's triangle. Do you guys remember the 8.6?
Yeah. I like that jump from 8.1 to 8.6.
Yeah, why are we jumping?
We're just covering those two sections. The other sections will either be covered in FST or if you take AP Stats.
I think we can do it now.
Hey, why are you saying that?
Because I can't.
Why?
No, my back always hurts.
All right, so 8.6, we are going to start this today.
Pick it up in a month.
Pick it up in a month.
Can we just do presentations?
No, we are going to get through this. Thank you. All right.
I think we should get a day off for the trauma of a virus.
Guys, you're getting 3 weeks off. We need to calm down.
Maybe 4.
Yeah.
We'll see how it goes.
All right, so like I said, if you have not filled this in, I want you to fill it in. And then I want you to write down the patterns that you notice. Guys, I need you to get focused back there. This is really theorem. Okay, so you need to use the binomial theorem to expand a binomial. Raised to a power. And then we're going to find binomial probabilities and test hypotheses. So we are going to learn about how the Pascal's triangle is related to probability today. Right, do you guys remember how to fill in Pascal's triangle?
Yeah.
Okay, so you're going to add the two numbers above it. So 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5, 5 plus 1. And then you always have ones on the outside. So this should be 7, 21, 35, 35, 21, 7, 1. Right, so the Pascal's triangle is what? How can we describe it? What's happening with our values? Yeah, they're symmetrical. Right? You can see that they start repeating themselves. Okay, so patterns that you notice, it is symmetric. Anything that we notice about the rows or the diagonals? Your first diagonal's what? All ones. So the diagonals, the first one is all ones. What about the second one? Okay, so it goes up by 1 each time. Starts at 1 and goes up by 1. What about the third one?
Random numbers.
No, they're not random.
I would say
So to get from 1 to 3, what would you do?
Add 2.
Add 2, 3 to 6.
3, then 4, then 5.
Yep, and then it just keeps going. Do you guys remember at the beginning of the year what else these are? They make the pyramids. So like if you have 3 dots, that would make a pyramid. If you have 6, it'd be 1, 2, 3, and then 1, 2, 3 for a total of 6. Remember at the beginning of the year we watched that video? You can watch that at home many, many times over. What are some other patterns? Do you guys remember how the rows go? What row do you start with? Yep. So it starts at row 0. And then we have row 1, row 2, row 3, row 4, row 5, so on and so forth. What is the row number equal? In row 3, what do you notice? In row 4, what do you notice?
There's a 3 and a 4.
Where?
Besides second number.
Second entry, right? Okay, so the row number is the second entry. What about the number of terms? Yes. So the row number plus 1 equals the number of terms in each row. All right, so this says that we use Pascal's triangle to find binomial expansions. In an earlier lesson, the coefficients of the expansion are the numbers in Pascal's triangle, but they are also what? They are actually combinations, which is what we just talked about with probability. Okay, so here's Pascal's triangle. The combinations, if you did 0, choose 0, 1, choose 0, 1, choose 1, all of those are equal to 1. So if we think of this in NCR form, the value of n, what does that match? This one's 0, this one's 1 and 1, 2, 2 and 2, 3, 3 and 3. What's your n? Yeah, your n is your row. Okay, so your n is your row starting with 0. Okay, that starts with 0. What about the r? So this goes 0, 2, 1. This goes 0, 1, 2, 3. Yeah, it's your position or your entry. Okay, again, starting with 0. Okay, and then this gives you an example of what the expansion would look like. The binomial theorem is for any whole number n, and then it kind of gives you this long, scary looking thing. So we're just going to break it down. So this says for any whole number n. So whatever your value of n is, okay, remember n is your row number, okay? So n is the row. All this is saying here, this is your row number. What is n minus 1? Like if your row number is 5, what would n minus 1 be? 4. If your n value was 3, it would be what? 2. So it's always just the number before it. So n minus 1, this just means this is your term before n. So n minus 2 is 2 terms in front of n. Okay? And this is just saying, oh, we start at n, we go all the way down to 0. With the second term, you start at 0 and you go up to n. And that's what we're going to look at with our first example. Okay, so we've actually done this before. Okay, so example 1, we're going to use the binomial theorem to expand each binomial. Okay, so if you have 5, your value is going to be n equals 5. So we're going to go to row 5. And in row 5, we're just going to write out what your coefficients are. Remember, row 5, the second number is going to be 5. Okay, so you have 1, 5, 10, 10, 5, 1. So in row 5, 5 is the second number, and there should be how many terms?
6.
Yes. Okay, now you are going to take the first, in this case, variable, and it's going to start at a to the 5th, and then go a to the 4th, a to the 3rd, a to the 2nd, a to the 1st. What's a to the 0?
0.
Yes. So I'm just going to put a to the 0 equals 1. In the next row, you're going to start with b to the 0, which is 1. And then this is going to go b to the first, b squared, b cubed, b to the fourth, b to the fifth. And then what do we do with these things? Yes, you're going to multiply down. It was or was not?
No, it wasn't for the door.
I know, that's it, yeah. Okay, so we are going to multiply down. Sometimes you'll see this written out like in the row, but then things get really long and crazy. I like doing the columns better. Phew. Thank you. Okay, so if I'm going to multiply down, this is 1 times a to the 5th times 1. Okay, so then I'm going to have a to the 5th. 5 times a to the 4th times b is going to be 5 a to the 4th b. This will be 10 a cubed b squared plus 10 a squared b cubed plus 5 a b squared b to the 4th, sorry, b to the 4th. And then 1 times b to the 5th. Oh, really? I like them. So if you look at this, it goes 5, 4, 3, 2, 1, none. The b's are going to go 5, 4, 3, 2, 1, none. Now, in this case, all the coefficients are going to match what's in Pascal's triangle, but when you start to have coefficients that are not 1, you are going to be multiplying those together. Okay, so in this term, your n value is 3. Okay, so when n is 3, you're going to get your coefficients, which are 1, 3, 3, 1. Okay, your first term is 2x. So this is going to be 2x to the 3rd, and then 2x squared, 2x to the 1st, and then 2x to the 0, which is just what? 1. Okay, so you can simplify that to 1. Now you are going to have to simplify these. So I'm going to write that underneath. So 2x cubed is really what? Yes, 8x cubed. 2x squared is 4x squared. And then this is the same, this is the same. All right, and then your last term is just y. So this is going to go y to the 0, which is just 1, y to the 1st, y to the 2nd, y to the 3rd. So when I multiply down, it's 1 times 8x cubed here I have 3 times 4, which is going to be what? 12. So this coefficient is 12. 2 squared is 4, 4 times 3 is 12, and then I have x squared and then y. Your variables should be in alphabetical order. And then 3 times 2, 6. So 6xy squared. And then this is going to be plus y cubed. All right, for the next one, we have a negative. So when you have a negative, you do have to take that into account. So your n value is going to be 4, and then you're going to use x, and then you're going to use negative y. Okay, so for 4, you have 1, 4, 6, 4, 1. So we're going to think about our properties of negatives here. So for x, I'm going to start with x to the 4th, and then x cubed, x squared, x to the 0, which is 1. And then with negative y, I have negative y to the 0, which is 1. Negative y to the 1st, negative y squared, negative y cubed, negative y to the 4th. questions for me about that setup? All right, now if you have a negative and you raise it to an odd power, what happens? It's gonna stay negative. So this is still negative y, but negative y squared becomes positive, positive y squared. Negative y cubed is negative y cubed. Negative y to the fourth is y to the fourth. All right, so then when I multiply straight down, I have x to the fourth. Here I have 4 and then times a negative 1 here, so this is going to be minus 4 x cubed y. This is going to be positive, so it's plus x squared y squared. This becomes negative, so negative 4 xy cubed. And then this is going to be plus y to the fourth. So the next one has a negative as well. Let's see if we notice any patterns when we have the negatives. Okay, and then can you set up part D?
I believe that you can.
Okay, so this is your 1, 3, 3, 1. And then we're going to use 2a.
I'm just walking around for Mrs. White. Can you sign that you've been taking electronic attendance? It's for that account. Oh. Just like for the year.
Yes. I'm saying yes, but I'm assuming that's what it's for. She was doing it. I'm like, oh, I can do that for you, because I'm sure you guys have a lot on your plate today. But with every question people ask me, I'm like, oh, I don't know. Thank you.
Okay, so then your value that you're plugging in first is 2a. And then you're going to be plugging in negative 3b. So lots of stuff happening here. So we have 2a cubed, 2a squared, 2a, and then 1. So 2a cubed is going to be 8a cubed. 4a squared, that's just going to be 2a, that's just going to be 1. And then with our negatives, we have negative 3b to the 0, negative 3b, negative 3b squared, negative 3b cubed. Notice that I do keep that negative inside the parentheses because it's being applied to the whole thing. Okay, so this is really going to be 9b squared. This is going to simplify to negative 27b cubed. All right, so when we multiply down the first one, we have 8a cubed. Here I have 3 times 4, which is 12. 12 times negative 3 is negative 36. A squared, b. 3 times 2 is 6. 6 times 9. This is positive 54. And then you have 1a and b squared. For the last one, it's 1 times negative 27, b cubed. So what can we say about our negative values here? If you have a negative as your second term, what happens? Every other one's negative. So it goes positive, negative, positive, negative, positive. Here it goes positive, negative, positive, negative. Does that make sense? Yeah, because if you have a negative, right, first you're raising it to an odd power, and then an even, and then an odd, and then an even. And anytime it's an even power, it becomes positive. Anytime it's an odd power, what happens? And it's going to be negative. And then why is the first one never negative? Because it's 1, right? In both of these, it was our second term. Okay? All right. I'm going to show you your calendar.